Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. There is something strangely soothing about the idea that time does not tick the same for everyone. That somewhere in this vast, quiet universe, two identical clocks, set at the same moment, might slowly begin to disagree. Not because they are broken, but because the universe is gently pulling on time itself. This is the soft wonder of time dilation. You can imagine two twins. One stays on Earth, grounded in the everyday rhythm of sunlight and sleep. The other climbs into a spaceship, gliding faster and faster until she begins to kiss the edges of light's own speed. To the twin on Earth, time passes as usual. But for the one in the ship, time stretches like a lullaby, sung in slow motion. Minutes for her are longer. Days expand gently. When she returns, her sister is older. The Earth has turned many more times, and yet for her, it was only a short drift through the stars. This is not fantasy, not imagination. It is a truth whispered by Einstein, held by the fabric of relativity. The faster you move, the more softly time flows, as if the universe tucks you into a blanket of stretched seconds. Imagine a beam of light inside a spacecraft. It bounces between two mirrors, moving up and down like a heartbeat of the ship. If the ship stands still, the light travels a short, straight path. But when the ship speeds through space, the light still bounces, but now in diagonal lines, longer paths because the ship is moving forward while the light tries to reach the same mirrors. The light's journey stretches, and if light takes longer to complete its path, then time itself must also stretch to match. That's how nature keeps its laws balanced. It's not the light that slows, it cannot slow, but rather time itself bends to keep the light's speed unchanged. This bending is what we feel as time dilation. It's invisible but real. It shapes how GPS satellites work. They orbit high above, moving fast, and time flows differently for them. Without adjusting for time dilation, your phone would place you hundreds of meters from where you actually are. The satellites tick slower than clocks on Earth. So even though we can't feel it in our bodies, we are always living inside this strange, drifting current of time. Now picture gravity like a silent hand pressing on the fabric of time. Near massive things, like planets, stars, and especially black holes, time runs slower, not because of speed, but because of weight. Time is like a soft river, and gravity can make it pool and slow. This too is a kind of time dilation. Astronauts aboard the International Space Station feel both. They're moving fast around the Earth, which should slow time, but they're also farther from Earth's gravity, which speeds time up. The two effects dance together, and the result is measurable, calculable. This dance of motion and gravity is the quiet music of relativity, a lullaby that gently shifts time's flow without ever making a sound. And while we live our days unaware, every moment we spend here is timed slightly differently than moments elsewhere. It is as though time breathes, more deeply in some places, more softly in others. It makes you wonder, could we use this strange truth to travel through time? Could we send someone far into the future just by making them move fast enough or place them beside something massive enough? The answer, softly, is yes. In a way, we already do. Astronauts aboard high-speed vessels age less than those on Earth. Not by much, but by enough that over long distances, over great journeys, the effect becomes significant. If we built a ship that could fly near the speed of light, and someone rode it for what felt like a few months, they could return to find the Earth changed by years, even decades. We could look into their eyes and see someone young, while everything they left behind has grown old. In this way, time travel to the future isn't a dream, it's a slow, quiet fact of nature. The faster you go, the slower your clock ticks, not because it breaks, but because it follows the rhythm of space-time's hidden laws. But there is no way back, at least not yet. We can stretch forward, but not rewind. Time's arrow still points in one direction. Entropy, the soft scatter of energy, insists that we move forward, always. And yet, by dancing with velocity, by curling close to gravity's pull, we can gently cheat the pace of time. This is a kind of time travel, not with flashing machines, but with patient mathematics and engines that dream of light. Some physicists imagine future explorers who, riding beams of power and bending close to black holes, might leap far ahead in time. They may see the world they left only in old recordings. They may return to find a planet that forgot them. Or perhaps they would never return at all, drifting endlessly into the future like a feather caught in a current they cannot escape. But all of this rests not on fantasy, but on facts that are already quietly guiding the ticking of your watch. It can feel strange knowing that time is not the same everywhere, that your heartbeat, your breath, your memories, all are riding on a stream that might twist if you move too fast or sink too low into gravity. And yet it is a beautiful thought too, that the universe allows such bending, such possibility, that the clocks we carry are not absolute but sensitive, poetic things, responding to our place in the cosmos. When you look at a star, know that the light you see began its journey long ago, when you were not yet born. That light has travelled through a universe where time flows differently, where seconds might stretch like clouds across a sleepy sky, and still it finds your eye, still it speaks across time. So the next time you check your watch or count the hours of a long afternoon, remember, time is not fixed. It listens to motion, it listens to gravity, it listens to where you are and how fast your heart is flying. Somewhere a clock is ticking differently, somewhere two mirrors are waiting for a beam of light to return, and time, always gentle, is flowing like water around the stones of speed and weight, drifting apart yet always connected. Let's drift deeper now into the quiet truth that time is not only measured by clocks or calendars, but by the way it moves through life itself. Think of a mountain standing still for millions of years. To us, its presence feels eternal, but for the atoms inside it, time still flows, gently, invisibly rearranging its molecules grain by grain. Or picture an old tree, its rings circling outward with each passing year. Time lives inside its wood, whispering through its leaves, recording the seasons in silence. These are slow dances of time, and they unfold differently depending on where they stand in the universe's gentle web of forces. Time dilation, though a concept built in equations and physics, is also felt in these long, patient stories. In places of great mass or fast movement, time doesn't vanish, it stretches. It becomes a different kind of river, not rushing toward a waterfall, but calmly meandering in wide, quiet curves. Now, take a soft breath and imagine the surface of a neutron star. It is the densest kind of star that still has a surface, packed so tightly with matter that a single teaspoon would weigh billions of tons. Near such a star, gravity is immense, so intense that time slows drastically. A clock left near its surface would tick many times more slowly than one kept far away. If you could visit, you might spend an hour there, and return to find that months had passed elsewhere. The pressure of gravity there doesn't just crush matter, it presses against time itself. It's not something you could feel directly, not like wind or warmth, but it's there. Scientists call this gravitational time dilation, and it means that the deeper you go into a gravity well, the more time curls and coils, like fog settling into a valley. This idea was proven not just by theory but by delicate experiments. Atomic clocks placed on airplanes, flown around the world, returned ticking slightly differently than those left on the ground. Not by much, just nanoseconds, but enough to remind us that time, even over small distances and speeds, listens carefully to motion and height. Your head, if you're standing, is technically aging faster than your feet. It's imperceptible but real. And in space, where satellites dance far from Earth's gravity, engineers must constantly adjust for this drift. It is as if every piece of technology we send into orbit must learn the rhythm of time all over again. These adjustments, these calculations, are not patches or corrections. They are acknowledgements. They are signs that we live in a universe where time is flexible, graceful, and deeply tied to the structure of everything. The more you think about this, the more mysterious time begins to feel. Why should time bend at all? Why should speed or mass make a difference? Some scientists believe it is because time and space are not separate. They are threads of the same tapestry woven into something called space-time. In this fabric, mass and energy stretch the weave, creating curves that light, planets, and people must follow. The more massive an object, the more it pulls on this fabric, bending not just the path of objects around it, but the flow of time itself. So when you feel the tug of gravity holding you to the Earth, you're also feeling a distortion in time. Your seconds, your minutes, your aging, they are part of that bend. In this view, time isn't something separate from space, it is shaped by it. Just as valleys and hills change the path of rivers, so too do stars and planets reshape the stream of time. Imagine what this means for a traveller moving close to the speed of light. Their ship does not change, their body does not feel strange. But to someone watching from a distance, everything about them appears slower, movement, heartbeat, even hug thought. Inside the ship, time feels normal. Outside, they are drifting through an elongated moment, like a drop of rain suspended in the sky. This is not a trick of perception. It is the reality written into the laws of the universe. And because of this, we can imagine a kind of time travel. Not the backward leap into the past, but a gentle voyage into the future. All it takes is speed or gravity, or both. We don't need a portal, we only need patience, fuel, and precision. There's a story scientists often tell about the twin paradox. One twin stays on Earth, the other boards a ship, accelerates close to light speed, travels for a time, then turns around and comes back. When they meet again, the spacefaring twin is younger, not by a minute, but by years. This is not just theory, it's a consequence of the math we trust in particle accelerators and space missions. And if one day we build ships that can fly fast enough for long enough, this kind of journey could become real. Someone might leave Earth and return to find everything changed. Loved ones older, cities grown, even languages evolved. It would be a quiet kind of time travel, not with fanfare, but with quiet sorrow and wonder. You could see the future, but never go back. And what of black holes? These mysterious creatures of the cosmos, where gravity folds time so completely that even light cannot escape. At their edges, the event horizon, time almost comes to a stop, at least to an outside observer. If you hovered there, seconds would stretch into centuries. The universe around you would age rapidly, while you experienced only a moment. This is the most extreme form of time dilation we know, and yet, it comes not from science fiction, but from equations that describe our universe perfectly. Time near a black hole becomes so slow that, in theory, it might allow someone to skip ahead through cosmic history simply by waiting in place. But the risks are enormous, and the technology distant. Still, the idea remains that by slipping close to gravity's deepest wells, we might ride time like a wave, emerging in a distant future, untouched. Time dilation teaches us something humbling, that our experience of now is not universal, that your now and someone else's now may be gently drifting apart like leaves on a pond. That time is not a single thread, but a woven fabric, pulled and pushed by the quiet forces of motion and mass. It reminds us that the universe is not in a hurry, that it does not demand we age together, and that sometimes, to move forward in time, all you need to do is sit still in the right place or move with the right grace. The softness of this idea brings comfort, that the universe is not rigid but responsive, that time can flex, that every star, every orbit, every heartbeat is not only marking time, but shaping it. And perhaps by understanding this, we come a little closer to peace, because we too are part of this rhythm. We are not trapped in time but riding its quiet current. And sometimes we may drift faster, sometimes slower, but always we are carried. Now let us return once more to the question that glows softly at the heart of all this. Could we truly use time dilation to travel through time? Not in leaps or flashes, not with roaring machines tearing holes in history, but gently, gradually, with the patience of physics and the quiet pull of gravity? The answer, as we now know, is not only yes, but that we already are. Each moment you spend closer to Earth's surface, you are aging just a little more slowly than someone in a high-altitude plane. Each satellite that circles above us ticks in a slightly different time than we do here below. These differences are tiny, barely felt, but they are real. And if they can be measured here, on our small blue planet, imagine what might be possible far beyond, where the speed of light is not just a limit, but a tool, and gravity becomes a sculptor of time's path. In a future where engines grow stronger and more efficient, we may one day build ships that drift near light speed, not for seconds or hours, but for months and years. For the people inside, life would continue as always. Meals, conversations, dreams, they would come and go with familiar rhythm. But outside their window, the stars would shift and warp, and time would begin to peel apart. For every year they experience, many might pass on Earth. The world they return to would be older, wiser perhaps, or maybe unrecognizable. They will have moved forward in time, not with magic, but with mathematics. Not by conquering time, but by listening to its subtle bends. This future travel would not be chaotic, it would be smooth and continuous, a glide into what comes next, leaving behind the now like a fading echo. And yet, for all this elegance, time travel in reverse remains a silent wall. The past does not welcome us. We cannot stretch time backward as we do forward. There is no known trick of physics, no arrangement of speed or mass that allows us to return to yesterday. Some theories dream of wormholes, tunnels through space-time that might fold two distant moments together, but these are whispers in equations, not tools in our hands. Even if such paths exist, they remain hidden behind the veil of what we do not yet understand. Perhaps it is better that way. The past is delicate. It breathes inside memories, not mechanics. And while time may carry us forward like a river, perhaps it flows only one way because the story must be written without edits, only reflection. Still, within that forward flow, we find grace. Because to move through time at different speeds is still a kind of journey. And the fact that nature allows this, that the universe gently shifts its rhythm based on how we move or where we stand, is a gift. It means that time is not just a line, but a landscape. It has curves and slopes, highs and lows. It can be navigated, slowly, carefully. We are all time travelers in this way, not only moving from one moment to the next, but doing so differently based on how we live, where we are, and how fast we move. Our watches may seem the same, but the universe knows otherwise. It keeps a deeper time, a time that bends and breathes and changes with the stars. This idea touches more than science, it touches emotion, because it reminds us that everything we love is part of time's tapestry. The people we miss, the places we remember, the dreams we chase, all are wrapped in this soft drift of seconds. And maybe, just maybe, the knowledge that time is not fixed can bring comfort, that there is no single now, that that every heartbeat lives in its own thread of time, overlapping but distinct, that somewhere in another frame of reference a moment you cherish might still be unfolding. This is not fantasy, this is the quiet truth of relativity, that time does not tick the same for all, that what feels gone may still be drifting slowly through another current. Even now experiments continue. Scientists fire particles through long tunnels, pushing them near light speed. They watch them live longer than they should, not because life has changed, but because time itself has slowed around them. The same laws that apply to galaxies and astronauts also apply to the smallest pieces of matter. Time dilation is not rare. It is woven into every part of the universe, from the vast arms of spiral galaxies to the quiet hum of an atom. And this gives us hope that one day we might not only understand these effects more deeply, but use them wisely to explore time with care. Perhaps we will build observatories near black holes, not to escape into the future, but to watch the universe unfold in fast forward, to witness stars being born, galaxies colliding and epochs passing, all while we float in the calm slowness of deep gravity. Or perhaps we will design homes that orbit safely in regions where time moves differently, offering new perspectives on what it means to grow old, to live, to remember. These are dreams, but they are dreams shaped by science, not impossible, just distant. In the end, time dilation does not give us control over time, but it gives us a deeper understanding of it. It shows us that time is not something we march through uniform and absolute. It is more like a field or a song. It can stretch and compress. It can echo and delay. It responds to where we are, how we move, and what surrounds us. And in knowing this, we do not lose time's mystery, we deepen it. Because to know that time is not fixed is also to know that our experiences are not fixed, that every moment is unique, shaped by the invisible geometry of the cosmos. So if you ever look up at the stars and wonder whether you could ride time like a wave, the answer is yes, in the gentlest way. Not with bursts of energy or sudden jumps, but with slow, patient movement. With respect for the quiet laws that guide the universe. We may never build a machine that takes us back to yesterday, but we already possess the ability to touch tomorrow a little early, to arrive before others by waiting in motion, by drifting through the gravity's embrace. And that too is time travel. Not the stuff of fantasy, but the whisper of physics, soft and real, moving always forward, like a lullaby written into the very shape of space. So close your eyes and listen to time. It is not a ticking clock. It is a flowing river. It carries you gently, always. And somewhere, in the current shaped by motion and mass, you're already moving ahead, one soft second at a time. In the deep velvet of space where light itself begins to hesitate, there lies a quiet place where time no longer hurries. A black hole is not loud, not wild, not violent in the way we might expect. It is sad, deeply calm, almost asleep. And beside it, something strange happens. Time begins to stretch like pulled taffy, soft and slow, delicate and deliberate. If you were to drift gently towards such a place, floating in a spaceship with no need to rush, you might not even notice at first. Your heartbeat would stay the same, the lights inside your ship would flicker normally, but outside the stars would move differently. The clock on your dashboard would begin to tick apart from the rest of the universe. And the closer you move toward the black hole, the slower your time would become. You wouldn't feel it, but you would be traveling into the future, second by gentle second. It helps to picture gravity not as a force pulling you down, but as a soft sag in the fabric of space and time, a stretched sheet, heavy in the middle. The more massive the object, the deeper the dip. Earth makes a dimple, the sun makes a wide bowl, but a black hole makes a canyon, a steep, endless funnel. Light itself must follow this curve bending downward, and time too curves. It drapes along this funnel, stretching thinner and thinner as it nears the bottom. If you hovered at the edge, at the event horizon, your clock would barely move at all compared to someone far away. A minute for you could be years for them. That difference is not imaginary. It is real, measured and deeply embedded in the equations of general relativity. Imagine two explorers. One remains on a safe ship, far from the black hole, watching and waiting. The other descends toward the edge, carried by a pod that's perfectly balanced to hover just above the horizon. They speak to each other, at first easily, voices carried through signals and waves. But then the replies begin to lag. Seconds become minutes. Minutes become hours. For the one who waits above, time flows normally. But for the one below, time is syrup slow. She speaks, and by the time her words arrive, her friend above has grown older. It is not because the signal is slow, but because the speaker's time itself has slowed. If she stays too long, her return will be like a traveller from myth, a visitor who left for a day, but returned to find a century passed. This is not fiction. It is the gentle reality of extreme gravity. We do not need to imagine such places as fantasy. Astronomers have seen black holes, not with eyes, but through the light they shape. They do not shine themselves, but their presence is revealed by how they bend the light of stars nearby, how they twist and stir clouds of gas. And in 2010, humanity glimpsed the shadow of a black hole for the first time, an orange ring surrounding a darkness where no light escapes. That image was not just a scientific triumph, it was a quiet proof that black holes are not ideas, they are places. Real, patient places where time does not rush, where clocks could rest for what feels like moments, only to return to a world changed. Inside the event horizon, no signal can escape, no light, no sound, no message. But just outside, there is a place where you could, in theory, survive. You could float, you could wait, but every second would carry you farther from the time you left behind. You would be aging more slowly, not in your body, but in the way your time connects to the universe. For you, it would feel normal, but to everyone else, you would become a relic, a whisper from the past, untouched by the decades racing ahead. You might emerge young, blinking at a world you no longer understand, or maybe you would remain beside the black hole, watching stars spin and vanish, knowing that somewhere, far away, the universe is galloping forward. This bending of time is not only a curiosity, it is a truth that stretches across every part of our understanding. From the slow orbit of a planet to the fierce collapse of dying stars, gravity is always shaping time, and black holes are the deepest wells of all. They hold the greatest gravity, and thus they stretch time the most. Around them, space is distorted, like glass melted into curves, and time becomes thick, syrupy, obedient to the mass within. It is not a danger you can see, but a quiet transformation. A shift so gentle that you do not notice until it is too late to return. Yet this idea is not only a warning, it is an invitation to wonder. Because if time can be shaped, perhaps it can be used. Not controlled, but followed. Not mastered, but witnessed. The edge of a black hole becomes not just a boundary, but a balcony. A place from which to watch the universe age like a sunset. A place where you, the observer, becomes separate from the rushing flow of time. You could see empires rise and fall, stars bloom and fade. You could see galaxies move like leaves on a pond, all from your still, quiet position at the edge of gravity's deepest pull. What does it mean to wait beside a black hole? It means surrendering to a slower rhythm, trusting that time is not broken, only stretched. It means learning that patience is not stillness, it is movement at a different pace. And perhaps, in this way, black holes are not just devourers but teachers. They show us that the universe is not fixed, that time is not the same for all, that motion, mass and gravity are all part of a story that unfolds differently for every observer. They remind us that our own lives, our own clocks are not the only truths. So the next time you close your eyes and wonder what lies out there, in the black, in the silence, imagine this, a place where time barely moves. A place where you could watch the universe unfold not in chaos, but in peace. A place where the flow of time itself becomes soft, slow, and astonishingly kind. Let's drift deeper now, past the veil of silence that surrounds the black hole, into the slower, stranger places, where time almost forgets to move. You can almost hear it, the soft hush of everything around you, the quiet absence of ticking, of urgency. Here, gravity does not pull in the way we know. It wraps, it holds. It curves the world into a soft spiral, bending not just space but the very rhythm of existence. Near a black hole, you begin to understand that time is not a background, it is a player in the story. And that story becomes more complex, more delicate, the closer you approach the edge of the abyss. A photon, the smallest light particle, travels fast, always at the same unchanging speed. But when it tries to escape the gravity of a black hole, something remarkable happens. It begins to lose energy, not speed, but frequency. Its colour shifts, from bright blue to softer red to deeper red, and then, as it climbs farther from the black hole's gravity, it fades. This is called gravitational redshift, and it tells us that time itself is slowing at the source. If you stood nearby and watched this light climb upward, you would see it stretch, as though the light were yawning through the fabric of time. It is a gentle reminder that not even light can escape the influence of gravity's slow song. For scientists, these strange effects are not only curiosities, they are measurements, tools, insights into the nature of reality. In their observatories and data centers, they calculate how time behaves near different types of black holes. Some spin, some do not. Some are small, the size of a mountain, formed from the collapsed heart of a star. Others are enormous, sitting quietly at the center of galaxies, with masses millions of times greater than our Sun. Around these giants, time bends not only sharply but deeply. A single hour spent close to their edge could contain centuries of cosmic history unfolding in the wider universe. What would it feel like to be there? What would it mean to exist in a place where the present becomes separated from everything else? You might not feel any difference inside your ship, hovering at a safe distance. Your body would age as always. Your mind would tick forward with its usual flow of thoughts and memories, but the outside world would accelerate. If you looked back toward Earth, you might see it spinning faster. Weather changing, cities glowing and fading, generations unfolding in flashes. The stars would move more quickly across your screen. The galaxy itself might seem to ripple with suddenness. And all the while, your own time would remain steady, safe, quiet. You would become, in a way, an island in the rushing river of time, untouched by the currents around you. This idea that time is not absolute challenges how we've always understood ourselves. We speak of seconds, minutes, hours, as if they are fixed, shared by all. But near a black hole, those units break apart. They lose their universality. Time becomes personal, it becomes local. 1 second for you is not the same as 1 second for someone far away. And though this feels impossible, it has been proven again and again by experiments, equations, and observations. Gravity does not simply tug on matter, it shapes time like clay. And the more we learn, the more we see that time is a thing we are always moving through, but never quite holding. Now imagine a spaceship not just circling Earth, but pushing outward, faster, faster toward the speed of light. At first, time slows a little, then more, then it becomes syrup, then honey. For the pilot, life inside the ship remains normal. Days pass, music plays, meals are eaten. But for those watching from outside, the pilot's time stretches thinner and thinner. Her seconds become minutes, her minutes become hours. The faster she goes, the more softly time moves around her. And if she turns and comes home, she might find that decades have passed on Earth. Her friends are older, her city has changed. The world she left is now a memory, wrapped in distance and time. This effect, called time dilation, is not a guess. It is not a poetic dream. It is measured, proven. Deep inside particle accelerators, tiny particles called muons fly near light speed. They should decay quickly, but they don't. They last longer, not because they've changed, but because time around them has slowed. In our laboratories, we have watched time stretch. We have seen the speed that bends the hours. And we know that if humans could reach such speeds, we too could ride that soft slope forward in time. We could leave behind the now and arrive in the after. But the price is motion. The faster you go, the more energy you need. Each step closer to light speed becomes harder, heavier, as if the universe is gently resisting. At light speed itself, time would stop completely, but no object with mass can reach it. The laws of physics hold us back, not cruelly but carefully. They do not forbid us from travelling far into the future. They simply ask us to earn it through speed and patience. And while we cannot yet build such ships, we can imagine them. Sleek vessels with quiet engines, sleep-in passengers, and clocks that barely move. Journeys that last moments for the traveller, but lifetimes for those they leave behind. These are not only theories, they are equations written into the shape of space and time. Einstein showed us that time is not a background, it is part of the scene. And when we move quickly, when we chase the speed of light, time itself leans back. It slows down, gives us fewer moments, and yet, for the traveller, all remains the same. This is the quiet paradox. Time changes, but you don't notice, Guy, because everything inside the ship, from your heartbeat to your thoughts, slows in harmony. You feel normal, but the universe is shifting around you. Even now, some scientists dream of using this effect for exploration. To send astronauts far across space, knowing they will return having aged less than those who sent them. They will become visitors from the past, carrying stories of stars and silence. They will see things we cannot imagine. And when they come home, they will find a planet that has spun many more times than they have. Their lives will be out of sync, not broken, just softly displaced by motion's gentle curve. And we will greet them not as strangers, but as time travellers who rode the edge of physics. All of this begins not in distant galaxies, but in motion itself, in speed, in the simple act of moving fast enough to make time slow. This idea changes how we see even the smallest things. A GPS satellite circling Earth must correct its clock every day to match ours. Because it moves faster, time flows slower. Without this correction, your phone would guide you to the wrong street. Our technology, our tools must now listen to time's gentle bends. We have stepped into an age where motion shapes more than distance. It shapes reality. And so we begin to understand that time is not one thing, it is not equal for all. It depends on where you are and how you move. It depends on the quiet partnership between speed and time. The faster you go, the longer you wait. The longer you wait, the farther ahead you arrive. And maybe in this gentle truth we find something both humbling and beautiful, that the universe allows us to touch tomorrow simply by moving quickly enough, that the future is not hidden, it is waiting just ahead on the curve of time bent by speed. This is the speed that bends the hours. It does not scream or shout, it does not flash or roar, it hums like an engine in the dark. It waits like a ship preparing to drift, and one day when we are ready, we may step aboard that ship. We may sit quietly in its cabin, close our eyes, and let motion carry us gently forward, not in space but in time. We will not feel it. But when we arrive, the world will have changed, and we will remember that all we did was move and let time follow. Let's drift deeper into this quiet truth, that speed, something we often associate with chaos and motion, can actually become a lullaby that slows time. Imagine again the traveller in her silver ship gliding through space faster than anyone before. Outside her window, the stars smear into long threads of light, not because they move, but because she does. Inside the ship, nothing seems unusual. Her pulse is steady, her thoughts are calm. But the clocks on Earth tick differently now. Her seconds are no longer the same as theirs. For each heartbeat she experiences, the world behind her takes an extra breath. This difference grows with every mile she accelerates, every hour she spends riding the silent curve of velocity. And though she cannot feel the change, it is real as the ship that holds her. Einstein taught us this, not through guesswork, but through a deep understanding of how the universe folds itself. His special theory of relativity showed that time and space are not separate. They are threads in the same cloth, and when you pull on one, the other must follow. So when you move quickly through space, time must compensate. It slows down for you, gently, quietly, with no protest. This is not a punishment or a prize, it is simply balance. The universe seeks harmony, even in motion, especially in motion. And as you move faster and faster, it whispers back, adjusting your time so that all its rules remain intact. This effect becomes extraordinary as you approach the speed of light. Time does not just slow, it nearly stops. For light itself, time does not pass at all. A photon born in the core of a star and destined to strike your eye takes millions of years to travel, but from the photon's own point of view, that journey is instant. No time elapses. It is a paradox, and yet not truly so. It is a sign that time is not absolute, not fixed. It flows according to motion. And for us, bound by mass, we cannot reach light speed, but we can imagine approaching it. And in doing so, we imagine a world where journeys become time machines, not into the past, but into the yet to be. Some scientists have envisioned ships that carry passengers to distant stars, using this principle not just for travel, but for time dilation itself. To the people on board, the trip might feel like a year or two, but back on Earth, decades or even centuries could pass. These travellers would become historians of the future. They would return still young to a planet that has changed beyond recognition. They would carry memories of a world that no longer exists, and their knowledge, their perspective would become a bridge between eras. Time dilation could stretch not only seconds but understanding. It could remind us that life in all its forms is not tied to a single clock. Even on Earth we feel the whisper of these truths. In particle physics laboratories, scientists accelerate particles to near light speeds. They see these tiny messengers live longer than expected, not because they have become stronger, but because time touches them more softly. In orbit, satellites experience less time than we do on the ground. The Global Positioning System, GPS, must correct for this daily. Without accounting for time dilation, it would fail within hours. Your phone's blue dot, your map's perfect path, they are gifts of relativity. Quiet, unnoticed gifts that make everyday life possible. And so, even though we cannot yet ride beams of light to distant futures, we are already living in a world shaped by motion's effect on time. Now imagine time not as a line, but as a gentle slope. As you walk slowly, you move along it like a casual stroll through a meadow. But when you run, when you push toward light speed, you begin to slide. Not downward, not into danger, but into difference. You fall behind time's usual pace, not by falling, but by flowing differently. And when you stop, when your ship returns and you step once more onto steady ground, you discover that you have arrived in a new world. The slope has carried you forward, farther than you knew. and all you did was move fast enough to let time change its tempo. This vision is not just for astronauts and physicists, it is for everyone who has ever wondered what it means to move through time, because the truth is, we all do. Every moment is motion, every heartbeat is travel. The atoms in your body move, the Earth spins, the galaxy turns, and all the while time listens. It bends gently to our path, adjusts softly to our speed. It does not resist, it does not judge, it simply flows, accommodating us in a dance so seamless we never notice. But it's there, in every orbit, every beam of light, every whisper of a particle rushing near light speed. The beauty of this understanding is not in its complexity, but in its simplicity. The faster we go, the more time yields. And though we cannot yet travel fast enough to see the full effect, we know it waits for us. Not like a door we must break through, but like a quiet path we are learning to walk. The science is certain, the math is steady, the possibility is real, all that remains is the journey. And perhaps one day someone will step aboard a ship that hums with the power of light, close their eyes and feel time slow around them. They will wake days later to find themselves in the far future, calm, whole, and carried there not by force but by motion's gentle grace. So we keep imagining, we keep building, and in our dreams the speed that bends the hours is no longer a curiosity, it is a way forward, a gentle reminder that the universe has always known how to stretch time, that it welcomes our curiosity, that it waits quietly for us to catch up. Now let's step softly into the closing curve of this journey, not a destination but a gentle slowing down of thoughts, like the soft hum of engines after long travel. The speed that bends the hours is not only a lesson in motion, it's a quiet transformation in how we see time itself. We are used to believing that time is firm, fixed, marching steadily forward for all things, for all people everywhere. But when we move quickly enough, the illusion fades. Time reveals its softness. It flows differently for those who dare to move with enough velocity. It wraps gently around travellers and carries them forward into new futures, like leaves drifting along different currents in the same wide ocean. For the astronaut who circles Earth, it is milliseconds gained, fractions of a second where her clock lags behind. But scale it up, stretch the velocity, and the effect becomes more than a mathematical curiosity, becomes a path into deep time. If she were to travel near the speed of light for just a few years of her life, she could return to a world transformed by decades or even centuries. Her journey would not require mythical machines or mysterious energy, just speed and space and the patience of light. And when she steps back onto the Earth, still young, she might find herself a visitor from the past, carrying memories that no one else shares. This idea is not only about ships or science, it is about perspective. It is about how time moves for each of us, depending on our own paths. Even now, you and I are not aging at exactly the same rate. Our altitudes, our speeds, the gravitational pull of where we sit, all change time's flow ever so slightly. We are each drifting in our own thread of time, woven together, but subtly unique. And when we understand that, we begin to see time not as a wall that divides, but a fabric that stretches and holds. We are not bound by a single beat, but part of a symphony with many rhythms, some faster, some slower, all real. And perhaps that's the deeper beauty of time dilation, not just the science, but the emotional truth it suggests, that we can move through time differently yet still remain connected, that someone can be gone for what feels like a moment to them, and yet a lifetime to us, and still the bond holds. Still, the story continues. And if someday we send explorers to the stars, riding ships that move fast enough to make the years stretch and bend, we will be sending not just science, but love and hope and memory. We will be trusting that time, though different for all, can still carry meaning between people separated by ages. In the quiet halls of observatories, scientists continue to study these effects. They measure the ticking of atomic clocks on fast-moving jets. They chart the lifespan of particles that last longer when pushed to high speeds. They see in number and graph the truth that Einstein once imagined, that time is not absolute. It listens to speed, it responds to motion, and it allows us to glimpse futures that we cannot yet reach with our bodies, but may one day touch with our machines, our courage, and our curiosity. But what will it mean to live in a world where time can be stretched, where hours can be bent? It may mean learning to say goodbye differently. It may mean sending someone into space knowing they will return young while you have grown old. It may mean building relationships that span not only distance but time itself. And perhaps that is not sad but beautiful, because it means we trust each other enough to wait, to believe that even when time pulls us apart, there is something deeper that connects us still. In science fiction, time travel is often sudden, dramatic, but in reality, it is quiet, patient. It happens in fractions over long distances, through consistent motion. It does not require magic. It does not break the rules, simply follows them with grace. The speed that bends the hours does not rush. It eases time open like petals unfolding. It shows us that the universe is not a fixed clock, but a living rhythm, responsive to the ways we move, the ways we dream. And so when you next look up at the stars, imagine the travellers already drifting there, not in fantasy but in physics. Imagine their clocks ticking softly, slower than yours, stretched by speed. Imagine them sleeping beneath unfamiliar skies, wrapped in time that moves like a whisper. They will return one day, stepping out of their ships like echoes from another era. And we will welcome them with questions, with stories, with awe, because they will have seen what we could not, and carried our hopes through the slowed flow of space and time. This is the gift of motion, not just distance covered, but time unfolded, not just places reached, but futures touched. And perhaps, long from now, we will not think of speed as something that moves us faster, but something that slows time for us, gently, lovingly, carefully, so that we may rest inside it even as the universe races ahead. And so the journey ends, not with a bang, but a breath. The speed that bends the hours is still waiting, still possible, still humming through the deep corridors of space, and one day when we are ready, it will carry us forward, not in chaos, but in calm, not in fantasy, but in truth. The universe is already prepared, and time, as always, will follow our lead, slower for some, faster for others, always flowing, always near. In the vast stillness between stars, far beyond the hum of machines and the voices of cities, the universe keeps time in its own quiet way. There is no ticking clock hanging in the sky, no hand sweeping across a great cosmic dial, yet everything moves, everything ages, everything unfolds with a rhythm so soft, so slow, that we often forget it's there. Galaxies turn like drifting snowflakes. Planets orbit in graceful loops. Light travels silently from one side of space to the other, and within all of this, time ticks, not sharply, not urgently, but with the steady patience of something ancient and kind. This is the soft ticking of the universe, and it is everywhere, even within us. Every atom in your body carries a memory of time. The particles that form you have danced in stars, cooled in darkness, and waited eons to become part of a thinking mind. The time that shaped them was not rushed. It was slow, winding, a gentle flow across cosmic epochs. Inside a hydrogen atom, the simplest building block of matter, time is marked by the soft vibration of its electron cloud, a quiet heartbeat of the universe, repeating with exact precision. Scientists have built clocks based on these vibrations, and they are the most accurate tools we have. They don't just measure seconds, they tell us that time is not a thing we invented. It is a truth that nature whispers again and again. But time is not always the same. It bends and stretches just as we've seen. Gravity pulls on it, speed reshapes it, and yet beneath those changes, there remains a deep consistency, a rhythm so delicate it holds galaxies together. The cosmic microwave background, the afterglow of the Big Bang, is one such ticking. It is a soft hum that fills the universe, a fossil of time itself. Its waves stretch and cool, and from them we learn how old the universe is, how fast it's expanding, how time itself has changed. This light has been travelling for over 13 billion years, and still it reaches us. Still it carries the gentle signature of time's beginnings. Even in deep space where silence seems complete, time continues to move. A pulsar, the collapsed heart of a dead star, spins with incredible precision, sending out beams of light like a lighthouse in the void. Some spin hundreds of times per second, their rotations so perfect they rival our best atomic clocks. Astronomers use these stars to measure time across the galaxy, and through them we realize something beautiful, that even death in the universe is rhythmic, structured, unfolding according to time's quiet pulse. The universe does not rush to end things. It lets them fade gently, slowly, with grace. And what of black holes, those silent giants whose gravity bends time to a crawl? Even they are part of this soft ticking. They grow slowly, devouring matter with no haste. They evaporate even more slowly through a process called Hawking radiation, a whisper of heat at their edge, taking trillions of years to make a dent in their size. Time around them is not broken, only stretched. Their ticking is slower, deeper, more patient. They remind us that even where time seems to stop, it does not disappear. It only changes its rhythm. On Earth, time feels faster, not because it is, but because we are surrounded by motion. Clocks tick, hearts beat, lights flicker. We mark hours and days, years and centuries, but even here in our busy world, the universe's soft ticking continues beneath everything. Trees count seasons in their rings. Rocks carry memories of ancient climates. Ice cores hold bubbles of old air, frozen whispers of time before history. Time writes itself into every surface, every cell. And we too are part of this record. Our bones, our memories, our breath, they're all shaped by time's gentle flow. Scientists once thought time was absolute, unchanging, but now we know better. We know it bends and breathes. We know it changes for the fast, for the heavy, for the far away. But we also know that deep beneath all those variations, time holds a thread of constancy. It links all things from the tiniest particle to the grandest star. It is the soft music that plays beneath existence, and we are always moving to its rhythm, even when we forget to listen. Sometimes we ask, what is time really? Is it just the ticking of clocks, the passage of events, the way we measure change? Or is it something more, something woven into the universe itself? The answer, whispered gently by every star and stone, is yes. Time is the way the universe remembers. It is how light travels, how matter moves, how life grows. It is not something we hold, but something we live inside. It is not rigid, but responsive. And though we may try to measure it with machines, the truth of time is softer than any tick, quieter than any bell. It is the slow unfolding of everything. So when you lie down at night and feel the stillness of the world, know that time is still ticking, not loudly but lovingly. It moves with you, not against you. It carries you gently like a stream carries a leaf. You are not racing time, you are floating within it. And whether you're moving fast or sitting still, whether you are near a star or deep in shadow, time holds you just the same. This is the soft ticking of the universe. It does not demand attention. It does not shout. It hums like wind in the trees, like a lullaby sung by the stars. And once you begin to hear it, you will never forget. Because it is everywhere, in the breath you take, in the orbit of moons, in the distance between galaxies. It is not something to fear, it is something to feel, something to trust. Time is not outside of you, it is inside you. It is the quiet companion of your life. And like the universe itself, it asks only that you move gently forward, second by soft second, into all that is still to come. Let us now wander more deeply into the fabric of this gentle rhythm, the soft ticking of the universe that carries on in silence, behind all the noise of our thoughts. Everywhere we look, we find its presence. In the curve of a fern unfurling, in the weathering of stone, in the glacial movement of ice, time reveals itself not as a force to be feared, but as a patient artist. It leaves marks not in haste but in whispers, etching age into tree trunks, folding mountains over millennia, guiding the pulse of coral reefs growing beneath the waves. This ticking is not mechanical, it is organic. It is the breath of nature, stretched out over centuries, tender and vast. In the heart of every galaxy, time flows differently. The gravitational pull of billions of stars bending space-time into soft spirals means that clocks near the galactic core tick more slowly than those farther out. Not drastically, just enough to remind us that time is not the same in all places. And though our minds struggle to sense it, our measurements confirm it. One part of the universe is always slightly ahead, another slightly behind. It's as if the cosmos is having a conversation with itself, not in words but in tempo. A star here blinks a little faster. A pulse over there lingers just a little longer. It's a dance choreographed not by music but by gravity and space and motion. Closer to home, our own Earth holds reminders that time is a sculptor. You can see it in the slow erosion of cliffs, the steady rise of mountains pushed by tectonic plates. You can feel it in your own body as cells grow and divide, as hair greys and skin remembers the sun. Time doesn't arrive all at once. It accumulates, like dust on a shelf, like layers of sediment settling in an ancient sea. And if you're quiet, if you let yourself listen, you can feel it. That slow movement beneath everything, not a countdown but a deep breath. The universe measures time not only through things that move, but also through things that decay. Radioactive elements, for instance, tick off years through half-lives, releasing particles at steady intervals. From these natural metronomes, we've learned to peer into the past, into bones buried for tens of thousands of years, into rocks that remember the dawn of the Earth. Carbon, uranium, potassium, all keeping time in their own soft way, telling us that long after hearts stop beating and cities fall, time continues its gentle song. Not to erase, but to record. Not to end, but to change. This soft ticking reaches even into empty space. Between galaxies where there are no stars, no sound, no light, there is still time. The vacuum itself has a rhythm. Tiny fluctuations appear and vanish. Quantum blinks that suggest even nothingness cannot escape the passage of time. These are the quietest moments in the universe, and yet they too are touched by time's hand. They remind us that time does not need witnesses. It does not require an audience. It continues softly whether we notice or not. Light is one of time's most faithful companions. When you look at a distant star, you're not seeing it as it is. You are seeing it as it was. The light that reaches your eyes left that star years, centuries, perhaps millennia ago. The farther you look, the deeper into the past you gaze. The universe is not just spread across space, it is spread across time. Telescopes are time machines, catching photons that have been travelling for ages, each one a tiny messenger from a moment long gone. And yet, when it reaches you, the light is new. You are the first to receive it. And so the ticking of time is both forward and backward, moving through you and into you all at once. Even the act of thinking is a kind of ticking. Your neurons fire in patterns, sequences. They rely on time to function. Without it, there would be no cause and effect, no before or after, no memory, no anticipation. Time is the thread that holds our minds together. It gives us direction, continuity, meaning. We live in time not just physically, but emotionally. We remember because of time. We hope because of time, we grieve because of time. It is not only the background of our existence, it is the shape of it. And yet time is gentle. It does not demand. It does not rush. It lets us move at our own pace even as it carries us forward. The universe has waited billions of years for us to become aware of its ticking. It has no need to hurry, and perhaps in realizing this, we too can slow down. We can breathe more deeply, look more closely, feel more fully, because in doing so we begin to move with time, not against it. Some wonder whether time had a beginning, whether there was a moment before moments, a time before time. The Big Bang suggests yes, a point where time itself began to unfold. And if that is true, then all we know, all we are, is part of a story that began in a single luminous breath. But even if we cannot see that beginning, we can feel its echoes, in the warmth of the cosmic microwave background, in the expansion of space, in the quiet drift of galaxies apart from one another. Time is not just a river, it is the path the river takes, carved into space by the memory of creation. Find yourself watching the shadows move across a wall, or listening to the rhythm of your own breath. Remember this: you are part of something much larger. You are part of the universe's great soft ticking. Your moments, no matter how small, are written into the same fabric that holds the stars. You're not separate from time. You're one of its many hands, one of its many hearts. And that is a kind of comfort, that the universe ticks not like a bomb, but like a cradle. not toward doom, but toward change. It is not rushing us, it is rocking us, gently, steadily forward. And we are here, alive inside that movement, listening, feeling, becoming. Now let us follow time to the softest part of its journey, the place where it no longer feels like a measurement or a rule, but a presence. Not something outside of us, but something that lives within us. The soft ticking of the universe is not only in the stars and atoms, but in the way we live and love. It shapes the way a child grows, slowly day by day. It moves with the rhythm of a lullaby, sung in the dark of night, counted not in hours, but in heartbeats. It marks the passage of a life not in decades, but in quiet moments. A shared look, a memory remembered, a breath held in wonder. This is time not as a line, but as a field, open, vast, surrounding us with calm. In ancient forests, trees hold time differently. Their trunks remember droughts and floods. Their leaves whisper of seasons long past. They stand quietly while the world changes around them. Each ring within them is a mark of time, not in haste but in patience. These trees do not rush to grow. They let time shape them slowly, gently. And when we walk among them, we too begin to slow. We begin to hear the rhythm that they've always known, that life doesn't need to move quickly to matter, that the soft ticking of time is enough. In coral reefs beneath the ocean, polyps build cities of calcium inch by inch. They do not know haste. They only know the shape of their work and the pulse of the tides. They grow in rhythm with the moon, with temperature, with the subtle cues of the sea, and through them time becomes something fluid, not a calendar, but a current. The reef ages with elegance, cradling life while it drifts in and out, generation after generation. This is another face of time, one that moves with water, not clocks, one that lets go of precision in favour of harmony. There is time in silence too, in the pause before a word is spoken, in the hush between two notes of music. These small spaces are not emptiness, they are fullness waiting to be heard. Without them, speech would lose its meaning, music would lose its grace. These are the quiet seconds that hold everything together. In those brief stillnesses, the universe is not standing still, it is listening. It is breathing. It is letting us feel the depth of time, not just its passing. The universe too pauses. It takes its time between great changes. Stars live for billions of years, burning slowly, steadily, before collapsing into something new. Galaxies drift apart over unimaginable spans, their paths shaped by dark energy and gravity's quiet tug. Even expansion itself, the way the universe stretches, is not hurried. It is steady, like a gentle breath drawn over an eternity. This is not chaos, it is choreography, and we, as small as we may be, are part of that dance. There is something deeply comforting in knowing that time is soft, not sharp. That we do not need to race to meet it, that we can move gently through life, letting the moments carry us rather than chase them. The soft ticking of the universe reminds us that presence matters more than pace, that being here fully is enough. And even when time seems to be rushing, when days blur, when years vanish, it is only because we've lost the stillness that lets us feel it. The ticking hasn't sped up. We've only stopped listening, and yet time remains kind. It does not punish. It does not forget. It continues faithfully, offering us each new second, each new breath, without asking anything in return. It forgives our rushing, it welcomes us when we slow. It offers moments not as currency, but as gifts. You do not need to count them to be rich. You only need to feel them, to live inside them, to let them unfold like petals in the warmth of awareness. In the far future, long after our species has moved beyond this planet, time will still tick. It will still stretch and bend, still mark the orbits of distant moons, still measure the flicker of stars being born. Whatever forms we take, wherever we go, we will still carry time inside us, not as a burden, but as a companion. It will guide our stories, cradle our dreams, and remind us always that nothing is ever truly lost. It only changes shape. Perhaps then we do not need to ask what time is. Perhaps we only need to feel what it does. It gives us beginnings, it carries us through middles, it allows for endings, and even after those it offers memory. Time is what lets things grow and rest, move and return. It is what gives love the chance to deepen, what gives sorrow a path to soften, what gives wonder the space to expand. So the next time you find yourself staring at the sky, or listening to your breath, or watching shadows shift across the floor, remember this: you are not outside time, and time is not outside you. It holds you gently. It waits for you patiently. It never hurries, and it never leaves. The soft ticking of the universe is not something to escape. It is something to cherish, something to lean into. And when your days feel too fast, when moments slip through your fingers like sand, know that time is not lost. It is still there, moving beside you, steady and true. You are a traveller, and time is your path. It stretches behind you in stories, and ahead of you in possibility. And it speaks not in clocks, but in presence, not in noise, but in silence. The universe ticks softly, and so can you.